Okay, we're back. We're still talking about the endocrine system, and this video is going to focus on the adrenal gland. Now, the adrenal gland, renal, is a root that should make you think of the kidney. And so here we see the adrenal gland sitting like a little hat right on top of each kidney. So we do have two adrenal glands. Now, this gland got its own video because it's actually fairly complicated. And it really just gets complicated in how many different layers there are doing how many different things. So let me start out. I added a couple notes to this image to point out where the outside of the kidney, outside of the adrenal gland is, right, the very surface here. And then the inside, deep in the adrenal gland. So if we start on the inside, kind of the core of the adrenal gland, it's a region called the medulla. And the adrenal medulla, we talked about this a little bit with the hypothalamus. It actually has neurons coming from the hypothalamus, and the sympathetic nervous system is going to trigger the release of epi and norepi, epinephrine, norepinephrine, from the adrenal medulla. That's part of your fight or flight response. Okay, so what we're primarily then talking about here is the adrenal cortex. And there are three layers of the adrenal cortex that we have to get through. So we have the zona glomerulosa, the zona fasciculata, and the zona reticularis. Isn't this fun? So the thing to keep in mind here is what's coming out of each of those. Okay? So the outermost layer, the zona glomerulosa, is secreting what are called mineralocorticoids. And the most important mineralocorticoid that we're going to talk about is called aldosterone. So the mineralocorticoids as a class basically deal with electrolyte balance, and aldosterone is going to be a hormone that acts on the kidney and tells it to reabsorb sodium, to conserve sodium, hold on to it, and as a byproduct of that, it actually eliminates potassium, right? So it holds sodium in to the body, and allows potassium to leave the body. So aldosterone, it primarily acts on the kidneys, but it can also act on sweat glands, taste buds. Now, while aldosterone is telling us to hold on to sodium, that kind of secondarily tells us to conserve water, right? Because water is going to follow that salt as we keep it in the kidney. This is released in direct response. So again, we don't need the hypothalamus here. These mineralocorticoids are actually released directly in response to things like decreasing sodium levels or increasing potassium levels. They can also respond to changes in blood volume. A decrease in blood volume or blood pressure would trigger the release of aldosterone, because if you hold on to the salt, you hold on to the water, and you can up that blood volume and blood pressure. It also is released in response to another hormone called angiotensin, and we'll talk about that a little bit more with the kidney. Okay, so that's our outer layer of the cortex. As we move a little bit deeper here, we get into the zona fasciculata, and the zona fasciculata releases glucocorticoids, and the most prominent, or the one you've probably heard of, is this hormone cortisol. Right? So there's other glucocorticoids, things like corticosterone, cortisone. So any of those ones, that should make you think this. Now, this is the region that responds to the hypothalamus. Right? So we have that corticotropin releasing hormone, which triggered the pituitary to release the adrenocorticotropic hormone, which triggers the zona fasciculata here to release things like cortisol. Now, the interesting thing with cortisol, we think of it as a stress hormone, but it actually has roles in multiple different things. So it does do things like speed up the synthesis of glucose. It tells adipose to go ahead and release fatty acids. So it has this glucose-sparing effect, right? It's trying to make glucose available in the bloodstream. Tells the cells to use those fatty acids instead. And then one of the key things, so you might have said, wait, corticosteroid, Like that sounds, or like cortisone, I use that as a cream. The glucocorticoids do have anti-inflammatory properties. Now, that sounds really good, but basically what you're getting is you're inhibiting the immune system, right? You're inhibiting white blood cells. You're like calming them, which in some cases is really important. You've got a rash, maybe you want to put a cream on it. But the flip side to this being anti-inflammatory is also to think about the fact that it is suppressing the immune system, right? So it's going to keep your immune system from acting as well. The deepest layer of the adrenal cortex, the zona reticularis, as you see here, is releasing androgens. This layer is also triggered by that adrenocorticotropic hormone. Now, these androgens, that is a class of hormones. We tend to think about these as like the male sex hormones, things like testosterone. But some of these androgens, once they're in circulation, can actually get converted into estrogens. So males do have some low levels of estrogen. That's coming from here. And then this is also a really important source of androgens in females. In a male, it's such a minute amount of the male sex hormones compared to, say, what the testes are producing. But in females, this is really our only source of this kind of male hormone. And these androgens are going to do things like support muscle mass and libido, things like that. And so the androgens are important as well. Okay. So if you're a little bit more of a graphy person, check out this table that kind of runs through those same layers and the same hormonal outputs. I pulled this from another book because I thought it was kind of a neat way to look at it as well in more of a tabular fashion. So use that image if that helps you. And I think that's it. Okay. All right. We'll see you again soon.